First, I'm going to measure the mass of the beaker. Next, I'm going to zero out the balance so the mass of the beaker is not included in the mass of the Sprite. Now I'm going to add the Sprite, 150 milliliters. And the mass of that is 142.6 grams. I'm going to repeat this process with the following liquids: 7-Up, Diet Coke, Coca-Cola, Coke Zero, cooking oil, low sugar juice, flavored water, hairspray, and perfume. Now I'm going to find the mass of a quarter, dime, nickel, and a penny. The mass of the quarter is 5.7 grams. The mass of the dime is 2.3 grams. The mass of the nickel is 4.9 grams. And the mass of the penny is 3.0 grams. I'm going to use the water displacement method to determine the volume of a quarter, nickel, dime, and penny. I'm going to use 10 quarters, nickels, dimes, and pennies in order to get a measurable value. Then I will divide the volume of each by 10 in order to get the volume of one of each coin. I'm going to start with 31 milliliters of water. Now there are 38 milliliters in the graduated cylinder. I'm going to start with 34 milliliters of water. It went up to 37 milliliters of water. For the nickels, I'm going to start with 40 milliliters of water. Now it's at 46.5 milliliters. For the pennies, I'm going to start with 39 milliliters of water. Now it's at 43 milliliters of water. Now I'm going to use the water displacement method to determine the volume of 1 teaspoon of glitter versus 1 teaspoon of celery seed. For the celery seed, I'm starting at 36 milliliters. Now the volume is at 39 milliliters. For the glitter, I'm going to start with 38 milliliters of water. Now the volume of the glitter is at 40.5 milliliters. Now I'm going to do a penny in oil displacement to see if the volume differs from a penny in water displacement. I'm going to start with 30 milliliters of oil. The volume went up to 34 milliliters. Now that I'm done with the lab, I'm going to follow proper laboratory procedure and clean up my materials. To calculate density, you must take mass divided by volume. To calculate the density of the Sprite, I divided 142.6 grams, which was the mass, by 150 milliliters, which was the volume, to get a density of 0.951 grams per milliliter. To calculate the density of the Diet 7-Up, I divided 140 grams by 150 milliliters to get a density of 0.96 grams per milliliter. To calculate the density of the Diet Coke, I divided 139.4 grams by 150 milliliters to get 0.929 grams per milliliter. To calculate the density of the Coca-Cola, I divided 141.9 grams by 150 milliliters to get a density of 0.946 grams per milliliter. To calculate the density of the Coke Zero, I divided 137.8 grams by 150 milliliters to get the density of 0.919 grams per milliliter. To get the density of the cooking oil, I divided 132.5 grams by 150 milliliters to get the density of 0.883 grams per milliliter. To calculate the density of the low-sugar juice, I divided 140.2 grams by 150 milliliters to get the density of 0.935 grams per milliliter. To calculate the density of the flavored water, I divided 143.5 grams by 150 milliliters to get the density of 0.959 grams per milliliter. To calculate the density of the hairspray, I divided 43.4 grams, which was the mass, by 50 milliliters, which was the volume, to get a density of 0.866 grams per milliliter. To calculate the density of the perfume, I divided 40.8 grams by 50 milliliters to get a density of 0.816 grams per milliliter. To determine the volume of a quarter, I subtracted the 31 milliliters of water that I started with from the 38 milliliter total to get 7 milliliters. I then divided the 7 milliliters by 10 quarters to get a volume of 0.7 milliliters for each quarter. To determine the density, I divided 5.7 grams by 0.7 milliliters to get a density of 8.143 grams per milliliter. To determine the volume of a dime, I subtracted 34 milliliters that I started with from the 37 milliliter total that I got, which was 3 milliliters. I then divided 3 milliliters by the 10 dimes to get 3 milliliters per dime as the volume. To determine the density, I took 2.3 grams divided by 3.3 milliliters, which was To determine the density of a dime, I divided 2.3 grams by 0.3 milliliters to get 7.667 grams per milliliter. To determine the volume of a nickel, I subtracted the 40 milliliters that I started with from the 46.5 milliliters to get 6.5 milliliters, and then divided 6.5 milliliters by 10 nickels to get a volume of 0.65 milliliters per nickel. To get the density of a nickel, I divided 4.9 grams by 0.65 milliliters to get 7.538 grams per milliliter. To determine the volume of a penny, I subtracted the 39 milliliters of water that I started with from the 43 milliliter total to get 4 milliliters. I then divided 4 milliliters by the 10 pennies to get a volume of 0.4 milliliters per penny. To determine the density of a penny, I divided 3 grams by 0.4 milliliters to get 7.5 grams per milliliter. To determine the volume of the celery seed, I subtracted the 36 milliliters of water that I started with from the 39 milliliter total to get 3 milliliters. To determine the density of the celery seed, I divided 2 grams by 3 milliliters to get 0.667 grams per milliliter. To determine the volume of the glitter, I subtracted the 38 milliliters of water that I started with from the 40.5 milliliter total to get 2.5 milliliters. To determine the density of the glitter, I divided 2.2 grams by 2.5 milliliters to get 0.88 grams per milliliter. I wanted to compare the density of a penny in oil to a penny in water. To determine the volume of a penny in oil, I subtracted the 30 milliliters of oil that I started with from the 34 milliliter total to get 4 milliliters. I then divided 4 milliliters by 10 pennies to get the volume of 0.4 milliliters per penny. To determine the density of a penny in oil, I divided 3 grams by 0.4 milliliters to get 4.5 grams per milliliter, which is the same as it is in water.